So this week we've just published a paper in Nature Geoscience, and in that paper we have found that there is oxygen being produced in complete darkness at the bottom of the Pacific Ocean. Now this is really, really exciting because up to now we've thought of the deep ocean as being an oxygen sink, and all of the oxygen that's available in the deep ocean comes about from photosynthesis in the upper ocean and on land. And then that oxygen diffuses into this ocean and sinks down into the deep ocean where it provides an oxygenated habitat. What we're showing now is that the deep sea is able to produce its own oxygen. So the origin of this story started about 11 years ago. We went out to the Pacific Ocean with an instrument to measure the consumption of oxygen at the seafloor. Now normally what happens is as animals and microbes move around in the sediments consuming organic material, they consume oxygen. So if you enclose a known area of seafloor, you can see the oxygen slowly go down over time. And what we've found is that the oxygen is actually increasing over time.
The fact that we've got another source of oxygen on the planet other than photosynthesis has consequences and implications that are utterly profound.
I thought the sensors that we were using were faulty, so I'd send them back to the manufacturer for recalibration and testing, and they'd send them back to me and tell me that everything was working. So I'd then go out to sea again with them and I'd see the same thing, oxygen increasing in these mesocosms over time. Over about 8 or 9 years, I kept getting these faulty readings in my sensors. So this next time that I went out in 2021, I decided to take another method to measure oxygen concentration. And when the instrument came up from the seafloor and we downloaded the data from the sensors, again, the oxygen was increasing at the seafloor, which up to then I thought was impossible. So suddenly I realized that for the last 8 or 9 years I'd been ignoring this oxygen production mechanism. Subsequently, in the last 2 to 3 years, we've been trying to explore the mechanism for this oxygen production.
The fact that we've got this source of oxygen produced by these manganese nodules. This is one from the bottom of the Pacific Ocean where Andrew Sweetman's been working, is really exciting and staggering.
We started focusing in on the electrochemistry of the nodules. We had a number of nodules with us that we put in to seawater, and then we started probing the surface of these nodules with these 2 platinum electrodes to look at whether there were voltages that we could detect on the surface of these nodules. And amazingly, what we found is as we were probing the surface, the voltages were jumping up and down in places, rising to almost a volt. So we suddenly realized that it was quite possible that what was happening was the same thing that happens when you drop a battery into seawater. It starts fizzing because the electric current that's generated was splitting water into oxygen and hydrogen. So this discovery of oxygen production at the seafloor in areas where you have these polymetallic nodules is really important because to power the green economy, we need to extract metals from the ground or potentially the deep ocean. So what we have discovered means that we're going to have to carefully think about if deep ocean mining goes ahead, where that mining should take place, because this oxygen is likely being used in whatever quantity that it's produced by the ecosystem to basically breathe. The other implications of this research is it potentially sheds light on where life began on the planet. This discovery has shown that, well, maybe there was another source of oxygen a long time ago, and aerobic life, or life that breathes oxygen, could have persisted before the rise of photosynthesis. And if it's happening on our planet, could it be happening on other planets too?